Welcome. In this video I'm going to show you how you can perform a modified log likelihood goodness of fit test using R and my stikpetR library. I'm using stikpetR Notebook, but the code will also work in, for example, RStudio. In this video I'll focus on how to perform the test, not so much on how to interpret all the results and if you should be using this test. I'm currently using R version 4.3 and only have the basic packages installed. So there are quite a lot of alternatives for this test, but in this video I'll just quickly show you how you can simply perform the test. I'll need some example data, so I'll load the general social survey data from 2012 adjusted for some example purposes. I actually don't need all the data, I just need one field from this, a nominal field, so I'm chosen MER1, which is actually the marital status. To give you a quick impression, just use the table function, and as you can see, there were, for example, 181 people who indicated to be widowed. Now, my stikpetR library is not available on CRAN, so you'll need to install DevTools and then use install GitHub and then just get it from my GitHub. Once you've installed it once, you can always load it just using any other library. And the function of interest actually only needs the data. If you want, you can also specify some expected counts you have already, and you can specify if you want to use a continuity correction, either Yates, Pearson or Williams, or the default is not to use any. So I can just use the function ts short for test, mod for modified, log for logarithm, likelihood, and then gof for goodness of fit, and feed it the data, and we get one table in a return. This table shows the sample size, the number of categories, the chi-square test statistic, the degrees of freedom, which is simply the number of categories minus 1, the p-value, which is probably the most interesting. There's also the minimum expected count and the proportion of cells that had an expected count below 5, and last but not least, the test that was actually used. So this p-value is the significance sometimes referred to. If it's below a predefined threshold, usually 0.05, we would speak of significant results, as in this case, because the minus 273 means we have to divide this 4.5 by 10 to the power of 273, so it's going to be ridiculously small. If that's the case, then we reject the null hypothesis, and in this case we would state something like that. Not all categories are equally distributed in the population. If you want, for example, if you had these expected counts, you can actually store them separately as a small data frame with the names of the categories and then the expected counts, and then we can actually add this to our function by saying that the expected counts are those, and that will give us a slightly different result. Alright, I hope this video was helpful and thank you for watching.